Good morning, students. I welcome you all for the fourth session of this video lecture on analysis of three-hinged arches. So, in previous sessions, we already know that how to calculate reactions and normal thrust and radial shear at various points on the arch. Now, let us take one more problem. The problem is like this: a three-hinged parabolic arch of 40-meter span and a rise of 10 meter is carrying a UDL of magnitude 30 kilonewton per meter on left half span. Find the reactions, normal thrust and radial shear at 10 meter from left support. Also draw the bending moment diagram. This is a new thing for us. So already we know that how to calculate the reactions, normal thrust and radial shear at various points. But how to draw the bending moment diagram we're going to see from this problem. So with reference to the problem, the sketch is like this: a three-hinged arch A, B, C. These at these supports the hinged will be there. This is subjected to UDL 30 kilonewton per meter, and we know that reactions at A, this is horizontal reaction HA, VA, vertical reaction VA, and horizontal reaction at B, HB, and vertical reaction at B, it is VB. Total span is 40 meter. Okay, then central rise of the arch is 10 meter. This is subjected to UDL. As we already know that how to calculate the reactions, so we'll not go in detail with the reactions. For this, for reactions, we can take a moment about any one support at either A or B. Then summation MA equal to 0 or summation MB is equal to 0, we're going to get the reactions. Similarly, summation FY is equal to 0, we're going to get the vertical reactions. So for this, the reactions, that are vertical reactions, VA will going to get 450 kilonewton, and VB will going to get 150 kilonewton. Okay, so next horizontal reactions. Okay, this is HA is equal to HB is equal to, the horizontal reaction will be 300 kilonewton. So these are the reactions. Already we know how to calculate these things. Now let us move on to the next. Again, we have to calculate the normal thrust, radial shear, and at 10 meter from the left support. That is at point D, which is at 10 meter from support A. We have to calculate normal thrust, that is N, and radial shear Q. Okay, so already we know that the procedure to calculate these things. Now directly I'll going to write normal thrust N is equal to 335.41 kilonewton, and radial shear Q is equal to minus 0.03 kilonewton. So these are the values. Okay, we already know how to calculate these values. This is nothing but H. Okay, then this is a normal thrust and radial shear at 10 meter from left support, that is at point D. Now the next important thing is how to draw the bending moment diagram. So if you want to draw the bending moment diagram, first we're going to calculate the bending moment values at different points, that is bending moment at A, bending moment at C, bending moment at B, then at some other points on the arch. Then how to calculate the bending moment is like this. Now see, now let us calculate bending moment calculation. Okay, so as we know, bending moment at A, MA is equal to 0. Bending moment at B, MB is equal to 0, and bending moment at C, M, C is equal to 0. Why these are 0? As we know, A, B and C are hinged support. So at hinged support, bending moment will be 0. Therefore, MA, MB and bending moment at C is equal to 0. Now at all these 3 points, bending moment will be 0. Now let us find out the bending moment at C, that is at D now. Now let us divide the total arch into two sections, that is portion AC and portion CB. Okay. Now in this, bending moment at A is 0, bending moment at C is 0. If you consider the arch portion AC, now we have to calculate bending moment at D. Okay. So bending moment at D, that is MD is equal to, bending moment at D, MD is equal to, so plus VA into 10, okay, minus H into YD minus 30 into 10 into 5. Okay, so that is if you want to refer the figure, this is the figure. Bending moment at D we are calculating. Okay, so this is a reaction. VA is equal to 450 kilonewton, and this is the reaction HA or H is equal to 300 kilonewton, and this is point A, and here it is a UDL. This is 30 kilonewton per meter, and see this distance, the point D is at 10 meter. Okay, and we don't know this vertical ordinate YD. Okay, so in previous problems we know that how to calculate the vertical ordinate using that parabolic equation. We know that YD is equal to, or Y is equal to 4HX by L square into L minus X. So therefore YD is equal to 4H is 10 meter and X is 10 meter. This is X, 10 meter. Okay, then divided by total span is 40 square, that is L 40 minus 10. So from this equation we'll get YD is equal to 7.5 meter. So the vertical ordinate YD, this is equal to 7.5 meter. Okay, now I want to calculate the bending moment at point D now. So bending moment at D is equal to, now see here, so VA. Now so for the sign convention for bending moment is, okay, for sagging it is positive, and for hogging moment it is negative. Okay, so with this is VA into 10, okay, minus H into YD, then minus 30 into 10. 30 into 10 becomes point load, and moment of this point load will be from D, it is 5. Okay, so therefore bending moment at D is equal to, VA is 450, okay, into 10, okay, then minus 300 into YD is 7.5 meter, then minus 30 into 10 into 5. So the bending moment at D will going to get, the moment at D is equal to 750 kilonewton meter. So this is positive, you have got positive bending moment. So the bending moment at D is 750 kilonewton meter. This is positive bending moment. Okay, this is positive bending moment. Now, as I told, the arch is divided into two sections, that is portion AC. Okay, in portion AC there will be a positive bending moment, and in portion CB there will be a negative bending moment. So in portion AC, the positive bending moment will be 750 kilonewton meter, that is at point T. Now in portion CB we have to calculate the negative bending moment. So now to find negative bending moment between, okay, C and B. So we have to calculate what will be the negative bending moment between C and B. Okay. Now the bending moment for this, you can see the sketch. This is point support B. So somewhere here we're going to get point E. Okay, this is C. Now take a section XX here. Okay, at a distance X from support B. Okay, at a distance X from support B, as we have already calculated, this reaction VB is equal to 150 kilonewton, and this H reaction 300 kilonewton, and take this vertical ordinate YE. Okay, so let us take a section XX at a distance X from support B. So and the ordinate here is YE. Now here X is not known. First we're going to find out this X, then we're going to calculate the bending moment at E. Y is also not known. Okay, and we know that the parabolic equation Y E is equal to 4HX by L square into L minus X. Okay, so that is equal to, now let us take this. Okay, so YE is equal to 4, H is okay, central rise is 10 meter, into X we don't know, keep as it is X, divided by total span 40 square into bracket 40 minus X. So therefore YE is equal to, okay, 40 into 40, it is 1600 X minus 40 into X square divided by 40 square. So this I can write it as 1600 X divided by 40 square minus 40 X square divided by 40 square. Okay, so therefore YE is equal to, so this here we're going to get this and this get cancelled. This is X minus, then 40 divided by 40 square, we're going to get minus 0.025 X square. Okay, right? So now you can calculate the bending moment at E, the bending moment at E, or bending moment at section XX. So let us write, this is bending moment at E is equal to, so as per the figure, okay, so bending moment at E is equal to, so 150 into X, again you have to see sagging or hogging, right? So plus 150 into X, then minus 300 into YE. Okay, minus 300 into Y. So bending moment at E is equal to plus 150 into X minus 300 into YE. So write this is equation 1. Okay. So therefore, so substitute this YE value in equation 1 we're going to get. So ME is equal to 150 into X minus 300. YE is X minus 0.025 X square. Okay, so therefore ME is equal to 150x minus 300x plus 7.5 x square. Okay, or bending moment at E is equal to, okay, so it is 7.5 x square, then plus 150x minus 300x, it is minus 150x. So write this equation number 2. Okay, this is the bending moment equation at point E. So here we don't know x here. First we'll find x, then substitute to the value of x here, then we're going to get the bending moment at E. Now how to find out the x values here for maximum, okay, for maximum bending moment value, okay, if the bending moment is to be maximum, then that is dou ME, that is moment ME should be equal to 0. That is dou M by dou X is equal to 0. That is dou by dou X of moment ME. So differentiate this equation with reference to X, then is equal to 0. Then we're going to get the X value. So therefore dou by dou X of Y, that is ME, is 7.5 X square minus 150X. This is equal to 0. So therefore differentiate this, that is 7.5 into differentiation of x square is 2x minus 150 differentiation of x is 1. This should be equal to 0. Okay. Then from this we can get x is equal to 10 meter. So x is equal to 10 meter. So what is this x? This is nothing but at a distance of 10 meter from support B, there is a maximum negative bending moment. Then what is the value of negative bending moment? We're going to see. Okay. Therefore, substitute this x is equal to 10 meter in equation number 2. So in equation number 2, substitute x is equal to 10 meter. So we're going to get, okay, maximum, okay, maximum negative bending moment. Maximum negative bending moment, that is ME is equal to, okay, 7.5 x square minus 150x. So that is equal to 7.5, x is 10 minus 150 into 10. We're going to get bending moment at E, that is minus, remember it is important, we're going to get minus 750 kilonewton meter. So what this minus indicates? Okay, so minus indicates, we're going to draw the bending moment diagram, then we're going to see what is this minus value. Now let us draw the bending moment diagram, that is BMD. Shortly we can call it as a bending moment diagram. So how to draw the bending moment diagram? Let us see. First step is to draw the arch as it is given in the problem. Okay, so this is the arch given in the problem. This is point C. This is support A, this is support B. Okay. Now, mark the point. We have calculated bending moment at D. So bending moment at D, and we have calculated bending moment, that is negative bending moment at E. Okay. Now, yes. Okay. So this point D is 10 meter. And this point B, E is also 10 meter from support B. Now how to draw the bending moment? As we know, the bending moment at A is 0, bending moment at C is 0, and bending moment at B is 0. And one more thing, you can see the sketch. So see the sketch. Okay. So from support A to C, there is a UDL. So UDL is there, and we are going to mark the bending moment at D. Bending moment at D already we have calculated, that is 750 kilonewton plus. So mark this 750 kilonewton meter. It is plus value, means above the arch you have to draw. At D it is 750 kilonewton meter above the arch plus. Then bending moment at E, just now we have calculated, it is minus 750 kilonewton. Minus means inside the arch you have to mark the ordinate. So here it is 750. Minus means it is below the arch. Plus 750 means above the arch. This is also 750 kilonewton meter. Now as you know, between A to C, UDL is there. So since UDL is there, this will be curve, and this is the maximum value. Okay. Then from up to C it is a UDL. Here also it is curve. Here also it is curve, because A to C UDL is there, and this is plus 750 kilonewton meter. Since C is at C, bending moment is 0. Whatever the line we are going to draw, it has to pass through C. It has to pass through C. Now, what is the bending moment at E now? Bending moment at E is minus. Minus means it is below. We have marked here 750 kilonewton. Now, C to B, if you observe the diagram, C to B, there is no load here. Okay, no load means you have to draw the straight line. Means this line and this line. Okay, so here to here it is curve. It has to pass through C because moment is 0 here. Then a straight line. Here it is minus 750 kilonewton meter, and again it is here 0. So you can observe this is positive because it is above the arch, and this portion is negative. Okay, so this is what bending moment diagram. Okay, this is called as the bending moment diagram. Remember, whatever the bending moment line we are going to draw, it has to pass through from C, because the bending moment at third hinge is also 0. Moment at A, B and C is 0. This is positive 750 kilonewton meter at D. This is negative minus 750 kilonewton meter at D. So this is what the bending moment diagram we're going to check. I hope you have understood the concept of how to draw the bending moment diagram. So this is what the session 4, we have solved one problem, and I hope you understood this. If any doubts are there or any confusion is there, you can feel free to ask me at any point, and let us hope we're going to meet in session number 5. So with some more problems on arches. Thank you very much.